Aviation Maintenance Publishers is dedicated to professionalism in the education and training of aviation technicians. To help meet the increasing demand for skilled personnel in the aviation industry, we have produced this series of videotaped programs on the practical applications of your technical training. These programs are designed to complement the personal instruction you are receiving. The information contained in this series is intended as a guideline and should be used in conjunction with the appropriate Federal Aviation Administration documents and manufacturer's publications.
Most modern aircraft today are constructed of strong, lightweight metals such as aluminum, magnesium, and titanium. Through the years, the rivet has remained the fastest, lightest, and most economical fastener used in aircraft construction. The physical properties of some metals make them particularly suited to certain applications in the aircraft. The use of rivets is governed by the materials of which they're made. Another factor in determining which rivet to use for a particular job is the strength required of the riveted joint. Will the rivet be joining structural members? Will it be attaching skin to the structure? Or will it simply be holding some decorative interior appointment in place? Then there are questions of what types of material are being joined, magnesium to aluminum, or different alloys of aluminum? If so, what are the alloys? It becomes apparent that with all these factors to consider, it's important that the aviation maintenance technician be able to correctly identify the different types of rivets and understand the application of each type. Rivets are identified by the shape of the manufactured head, the marking on the head, the rivet part number, and the size. At the turn of the century, the United States was quickly becoming an industrialized nation. Metals had to be manufactured to certain standards. From this need came the Society of Automotive Engineers Standard, or SAE. The military services then implemented the Army-Navy Standard, or AN, now referred to as the Air Force-Navy Standard. This has been converted to the Military Standard, or MS. You may, however, still see the AN code letters used in rivet identification. A typical part number under current standards would be MS 20470 AD5-6. Using the Air Force Navy or AN part number, we find the same rivet would be identified as an AN 470 AD5-6. You can see that under the MS part numbering system, the number 20 has been added in front of the 470. Each set of letters and numbers has its own meaning. Let's break the part numbers down into their various components. The MS, or AN, is the standard to which the rivet is manufactured. The 20470, or 470, indicates the head style. The AD indicates the material composition or alloy. The number 5 tells us the diameter of the rivet shank in 30/2 of an inch. And the -6 indicates the length of the rivet shank in 1/16 of an inch. Let's examine each element of the part number in detail. Aircraft rivets will have either an MS or AN standard designator. combined with a number indicating the head style. There are two basic rivet head styles that are manufactured for aircraft construction: the 100-degree countersunk head and the universal head. All aluminum alloy rivets with 100-degree countersunk heads will be identified with the MS 20426 or AN 426 code number. All aluminum alloy universal head rivets will have the MS 20470 or AN 470 code number. The 100-degree countersunk rivet is used where a smooth surface is of greatest importance. Notice the measurement of the 100-degree angle. The universal head rivet looks like a half moon with the top slightly flattened. It's rapidly replacing the round head and brazier head rivet in aircraft construction and repair. Rivets can be made of several different materials, including steel, titanium, iron, and Monel, as well as aluminum. However, only aluminum rivets should be used to join pieces of aluminum. Dissimilar metal corrosion could result if another type of rivet were used. The letter or letters following the first group of numbers in our example identifies the material from which the rivet is made. Even among aluminum rivets, there are several different alloys that can be used. This is because corrosion resistance is further improved if the rivet is of the same or nearly same alloy as the material being joined. Here are several examples of aluminum alloys and the rivet code letters that identify them. Each alloy is identified on the rivet head with a particular identifying mark. The 1100 H14 aluminum alloy rivet has a smooth head with no markings. It's a commercially pure aluminum rivet and is used mostly for non-structural parts, such as map cases, where strength is not a major factor. The 1100 H14 aluminum alloy rivet is identified in the rivet part number with the code letter A. The 2117 T4 aluminum alloy rivet is commonly called the field rivet. It's used in most areas of the aircraft and needs no special processing. The 2117 T4 rivet is identified by a dimple in the head and by the letters AD in the part number. The 5056 aluminum alloy rivet has magnesium as its main alloying element and is generally used when riveting magnesium parts. It requires no special treatment and is identified by a raised cross on the head and by the letter B in the part number. There are two special purpose rivets in use in aviation today. They are the 2017 T4 and 2024 T4 aluminum alloy rivets, commonly called icebox rivets, because of the special process they must go through before they may be installed on the aircraft. Temper is an important factor in riveting with aluminum alloy rivets. They can be hardened and annealed or softened in the same manner as sheet aluminum. The rivet must be relatively soft before a good shop head can be formed. The 2017 and 2024 T4 rivets are annealed before being driven and begin to age harden within a few minutes after being exposed to room temperature. Therefore, they must be used immediately after quenching or be placed in cold storage. The most common method for storing heat-treated rivets is in an electric refrigerator below 32 degrees Fahrenheit or 0 degrees Celsius, hence the name icebox rivets. These rivets may be used for a period of up to 2 weeks in cold storage. After that time, they must be reheat treated. The heat treating process may be repeated several times if done properly. Of the two icebox rivets, the 2024 T4 rivet has the greatest bearing and shear strength. It's identified by 2 raised dashes on the rivet head and by the letters DD in the part number. The 2017 T4 icebox rivet is identified by a raised teat on the head and by the letter D in the part number. The 2 icebox rivets are used in areas of the aircraft where more than the usual amount of strength is required. Up to this point, we've learned to identify rivets by head styles and head markings. But to completely identify a rivet, we must also know how to measure rivet size. The last 2 sets of numbers in our sample part number tell us the diameter and length of the rivet. The 5 in the part number indicates that the diameter of the rivet shank is 5/32 of an inch. Diameter of the rivet shank is always measured in 32nds of an inch. The diameter of the rivet must not be less than the combined thickness of the parts to be riveted. The most commonly used rivet diameters are 3/32, 4/32 or 1/8 inch, 5/32, 6/32 or 3/16 of an inch, and 8/32 or 1/4 inch. The last number in our example indicates the length of the rivet in 1/16 of an inch. Our -6 rivet is 6/16 or 3/8 of an inch long. Countersunk rivets are measured from the top of the rivet head to the end of the shank. The universal head rivets are measured along the length of the rivet shank only. The length of rivet shank protruding through the material to be joined before driving should be at least 1 1/2 times the rivet diameter. Thus, in our example, the amount of rivet shank protruding through the material must be at least 1/4 of an inch, rounding to the nearest 16th. Let's review what we've learned about rivet identification. The MS or AN in the rivet part number is the standard designator and is found in combination with the number identifying the head style. The letter or letters following the first set of numbers indicates the material of which the rivet is made. The diameter of the rivet shank is measured in 32nds of an inch. Our example shows that this rivet is 5/32 of an inch in diameter. The last number in our example is the dash number and indicates that our rivet is 6/16 or 3/8 of an inch long. Remember, countersunk and universal head rivets are measured differently. Both of these rivets are considered to be the same length. Both are indicated by the dash number 6. Throughout your career as an aviation maintenance technician, you'll probably be using rivets as the primary means of fastening. A review of the material in this presentation, combined with textbook study and reference to publications such as the Aviation Maintenance Handbook and Standard Hardware Digest, published by Aviation Maintenance Publishers, will strengthen your knowledge of this most important single piece of hardware in aircraft construction and repair.